we haven't really, so for the purposes of the recording, okay, have you started the recording? All right. Okay, so pas tayo. So in this problem given last time, there is only one triangle that's going to come up. Anyway, you know the computation. So beta 1, 49.588, beta 2, 130.411 degrees. However, the second case is impossible because if you compare this beta angle with the alpha angle, their sum is already going to be larger than 180 degrees. So if you try to solve for a gamma sub 2, it's going to be a negative angle. But we only allow for negative angles if we are not inside a triangle. Inside a triangle, the three angles have to be strictly between 0 degrees and 180 degrees. So the second case is impossible. The first is possible, and C is 5.7. Although it was rather interesting, you pointed out that it seems C is equal to 5.7 exactly. So if I couldn't find the time, I'm gonna look into this. Is C actually equal to 5.7 exactly? But let's leave that for a different day.
What if
So
try po using the circle tool sa one to? Meron pong shapes oh.
sorry, where are we? Are we talking about the previous problem, or are we now here in
Ito
this
po,
example?
yung sa ngayon po, what if you use the circle tool to draw po?
Sorry, what did I what?
Yung circle tool po. Yung shapes po.
No, no shapes. I guess I could do that. Pero would I be able to draw them to be tangent to each other? Sige nga, subukan ko. Sige, sige. Let's make it so. I think, you know what? Sige nga, let's use technology.
Ha ha ha. Oh no, I fear that magkaka-copy paste na to po. Magkaka-copy paste
Okay.
na.
Yeah, lots of copy pastes. Oh, wait.
Yung,
So to draw a
pwede
circle,
na pong galawin.
okay, and then another circle. Tapos pwedeng extend na lang. Okay, perfecto. Okay, that's fun. All right, so we have the centers. Okay. Let's call them A, B, and C. Tapos A, B, and C. It looks like a right triangle. It looks like it's isosceles, but I don't want to change the figure anymore. All we know is that sine A, sine B, sine C are in the ratio 2:3:4. However, it's the radii that we have to find the ratio of. So let's call them X. So if that's X, that's also X as marked. And then for circle B, the radius is Y. For C, the radius is
Oh, I
Z.
see where this is going because x plus z is equal to AC and then the others will sum up to.
Yeah. All right. So that means small b. Well, why don't I start with A? All right. Small a is Y plus Z. B is X plus Z. And C is X plus Y. In the law of sines, it's really these which make an appearance. All right. So because A over sine A equals B over sine of B equals C over sine of C. So that means A is to B is to C as sine of A is to sine of, sorry, is to sine of B is to sine of C. And so therefore, the ratio of A to B to C, so that's Y plus Z, and is to X plus Z, is to X plus Y, is equal to 2, is to 3, is to 4. All right, so this is what we're going to use. to try to figure out how to determine the ratios of X, Y, and Z. Joshua, can I give you a couple of moments to try to work this out? I just want to see how you're going to do.
How I'm
How
going
are
to
you going to try? All right. Can
already
you work on this?
this already looks like po the problem at the exact end of the chapter.
Mhm. Sorry?
This looks like a problem at the end of a chapter of a book.
Uh, yeah, actually, we're all getting the all end of chapter problems.
Y plus Z is to X plus Z. What if we make it not just 2 to 3 times 2 to 4, because that's a kind of ratios are hard to work with na per se. So just make it 2x to 3x to 4x. Let x be anything. Because
All right, so that's what I'm interested in. But of course, let's not use X.
A something, B maybe.
Uh, also not A because we have A, B, and C. I'm sure there are
Oh,
other letters.
I hate
N,
the
N,
I hate
N,
the way. N, yeah, pwede. N.
N.
N. All right. Okay. So 2N and then X plus Z is 3N. All right. And then
And
X
after
plus
that,
Y
you
equals.
will have two x plus two y plus two z, or x plus y plus z. No, two x plus two times x plus y plus z equals 2, 3, 4, which is 9. What? Yes, 9, 9,
Mhm,
9n.
9N.
So x plus y plus z is 9 over 2n. So now we
Mhm.
can figure out what z, y, and x are in terms of
Yes. Good.
it will be eliminated
Uh,
anyway because you will just take the ratio.
mhm. All right. So what is X in terms of N?
So 9 halves and minus 2n is what was 9 halves? 4 and 1 half minus 2n is 2 and 1 half n. So 3 half n.
Or 5 halves?
Ay, sorry. 5 halves n pala.
Okay.
Tapos on 9 halves minus 3n is 1 and a half, which is actually 3 halves n. And
Mhm.
then 1 half na lang yung z. 1 half n.
All right. So therefore, the answer is
1 is to 3 is to 5.
1:3:5.
If you were to replace po yung ratio ng signs ng ABC into, let's say po, H na? I still have bad na eh. PQR siguro. Can you still
Mhm.
can you still find the ratio? Can you find the ratio of the radii of the three circles in terms of PQ and R?
Yeah. Oh, in fact, you can find the para mangyari, we're just gonna replace. So actually, ang sinasabi natin dito kasi 2n is A. Itong 3n, this is B, which is well, X plus Z, which is B, and then X plus Y is C. So if what we're provided with are the values of A, B, and C, you can solve the system to solve for X, Y, and Z. So that's going to allow us to solve for X, Y, and Z in terms of A, B, and C. So in fact, the method that you did is what's going to work just fine here. So kasi diba, what you did is, actually you added the three equations. So 2 and then X plus Y plus Z equals A plus B plus C, or the perimeter P. So therefore, X plus Y plus Z is P over 2, or S, the semi-perimeter.
Hmm.
So S, which is P over 2. So that means X is equal to S minus A. All right, kasi ano di ba? Y plus Z equals A, and then X plus Y plus Z equals S. So that means X is S minus A. Similarly, Y is S minus B, and Z is S minus C. All right, but I suspect you've seen this before.
No, maybe I've
Not
seen this before po. But then for some reason, my brain thinks I've already done it before.
all
Because
right. Okay.
yung una ko pa lang may nakita po, the A, B, and C are centers of circles. I initially thought, are they
Mhm.
tangent?
Yeah, that's tangent. So it all fits nicely. All right. So a consequence of the law of
Ano kami,
science
ano
is
po,
that.
may ano pala po akong question po
Marami
dyan.
po kaming ginawa
Yung
before
ano
na
po,
ano eh.
yung,
Oh, sure. Go ahead. Sige.
yung sa, yung, ay, pakiakyat po, yung sa mga, saan po nag-intersect, yung in between X and Z, tsaka in between Y and X, tapos, does the triangle formed by those so, kumbaga intercepts po, does it have any significance to the triangle?
I'm sure we could come up with something in terms of I'm thinking maybe a similarity result. So tingnan natin I'm thinking I wonder if it's going to be similar. Tingnan natin. Let's do a quick doodle here.
Imposible po ang similar kasi pwede na po switch yung angles eh. Pero baka po, this is area constant or something? Kasi parang, I remember seeing this one time before. I don't know if it's the price. I remember it's not a problem eh. It's some sort of theorem. I think po I saw something. So, parang baka may deja vu po ako. I remember something about yung triangle
Oo
forming.
nga so parang baka meron nga, but it's something that I'm not sure exactly. So I'm trying to see if writing stuff down will help me, if it will help me remember if there's anything special that can be said about this triangle. Um, hmm, how far tapos ito. Wait, hold on. Ito kasi I saw Swisto. So I'm looking at the angles. So this would have to be therefore 180 degrees minus alpha over 2. So that's 90 degrees minus alpha over 2. And then similarly, this is going to be 90 degrees minus gamma over 2. A,
Yeah, I
B,
think so.
C. Let's label D, E, F. So angle FED is going to be 180 degrees minus 90 degrees minus alpha over 2 minus 90 degrees minus gamma over 2. 180 minus 90, that's going to disappear. We are going to get alpha plus gamma over 2. But the only nice thing I can say about alpha plus gamma is that it's 180 degrees minus beta over 2. So this is going to be 90 degrees minus beta over 2. So let me put that in orange. So this is going to be 90 degrees minus beta over 2. But, well, I see that it's the same as this one and also the same as that one. So as far as similarity is concerned, you're right, hindi siya magiging similar because the angles of DEF are not alpha, beta, gamma, but really 90 minus alpha over 2, 90 minus beta over 2, and also 90 minus gamma over 2. Now, as for the sides themselves, um, I doubt. But as for the area, how about for a different day? All right. Is there anything that can be said about DEF? Where right now nothing specific comes to mind.
Opo.
All right. I'm afraid if we do the exploration right now, we might consume time. I think problems like this it can be explored when you know, when when we have free time.
Opo.
All right. Okay. So let me get another note. Anything else interesting about triangle DEF? All right. Okay. Now, a consequence of the law of sines that I'd like to talk about is how we can use it to find areas. So let's say we're given, ito, let's say this is A, B, and C. Okay. Let's draw this, let's draw this altitude. And as usual, this is A, this is C, and then down there it's B. And then let's call this um, H. So the area of triangle ABC is 1/2 base times H. ABC. Actually, ganito, claim. Let's use a different color. Claim. The area of triangle ABC. I don't know if I've used this notation, but when you have a polygon and you put the name of the polygon inside brackets, that represents the area. So the claim is the following. This is equal to 1/2 AB times the sine of angle C. So here is A, here is B, and C is the included angle, the angle between them. But we can also have computed it this way, 1/2. Let's take the sides A and C. So now we're taking a different pair of sides. Earlier it was AB, this time A and C. A and C
Well, of
multiplied by the
course,
sine.
you can just switch the variable. It will just all be
Yeah.
different.
Well, 1/2 AC sine B and also 1/2 BC times the sine of angle A. All right. So this is what I wanted to prove. So way to argue would be as follows. So let's say we construct this perpendicular, call this H. Okay, and from the figure, what we see out of this is that sine of C is equal to H over A. So therefore, because the area of triangle ABC is 1/2 base times height, what we could do is take that equation and solve for H. Okay. We can replace H with A times the sine of C. And that's how we end up with one of the three formulas, 1/2 A times B times the sine of C. All right. And lest you wonder, maybe this argument works only if H is acute. So the thing with an acute triangle is that all altitudes are going to be inside the triangle. If you have an obtuse triangle, some altitudes are going to be outside the triangle, but even if that were to happen, we're still going to be okay because let's say the figure uh, looks like this. This is C, this is B, and then this is A. So this is small a, this is B, and this is C, opposite. If we draw the altitude that's perpendicular to AC, it would be this. All right. But fortunately, in this case, if you try to find sine of C is still going to be h over a. This time, the right triangle you're looking at is going to be CBD, where D is the foot of the altitude, but the sine of C is equal to h over a, whether or not D is between AC or point D is beyond AC. So sine of C is h over a, and in both two illustrations, the area is still 1/2 base times height. All right. So this shows that yes, ABC is equal to 1/2 AB times sine of C, the first formula. And the same argument shows us that, yeah, we should also be able to compute that as half of AC times sine of B, also half of BC times the sine of B. All right, so it's a quick example. So start with, something really, really basic. Example, in triangle ABC, AB equals 7, and then BC equals 4, and angle B equals 135 degrees. Find the area of triangle ABC. Okay, sorry to draw this. B is obtuse, 135 degrees. And then we have the shorter side, BC, which is 4, and the longer side, AB, which is 7. And we are interested in finding the area of triangle ABC, given the data that we have here. We can use directly the formula ABC. Because 135 degrees is between 4 and 7, so this is merely half of 4 times 7 times the sine of 135 degrees. Joshua, tell me, what is the sine of 135 degrees?
It's the sine of 45 degrees, which is square.
Yes.
Yeah, square.
Which is square root of 2 over 2. So we end up with 7 square root of 2 as the exact area. But of course, it's possible to find the area without using that formula. All right, kasi pwede naman gawin something like this.
Lupat na yata.
Okay. If that's 135 degrees, if you draw the height, okay, this is going to be 45 degrees, 90, 45 degrees. And the fact that this side is 4 allows us to determine what the height in orange is. So the height is, kasi you have a 45, 45, 90 triangle. 135 happens to be supplementary to 45, which is a special angle. So that height is going to be 4 over the square root of 2. So the area of ABC is still 1/2 times the base, 7, times the height, 4 over the square root of 2. So that's still going to be 7 square root of 2. All right. Okay. Madali lang ba?
Opo.
All right. Madali lang pala. Di hirapan natin.
Wala. Bro?
Kaya mo yan. I mean, I'm sorry for saying hirapan natin kasi mamaya pag sabihin na hirap, psychologically, ayaw na natin. Okay. Pero kaya mo to. Let me just draw the following configuration. P, Q, R. Not drawn to scale, all right? And this is S, T, and then U.
Looks like
And suppose, yeah, all right. Suppose that T Q equals TS. Yeah, let's make it. Let's make it like this. SQ is twice ST, and then TR is 3 times TU, and UP is 4 times US. Suppose the area of triangle UST equals 5. Find, what do you think?
find it. Oh wait.
Find the area of,
Area of PRQ.
yeah,
What?
PQR.
Oh no.
But we already know the area of the triangle in the middle, 5.
We can find. Wait, we can't find. Okay. Is it possible? I don't think so.
Should be.
Hmm.
Let me give labels to, let's call this X, Y, and Z. ST, TU, and US are respectively X, Y, and Z. Yeah,
Is
you have those.
our STQ collinear?
RS.
Trapezium po eh. Kaya po medyo nahinto po ko. Baka trapezium.
Wait. Let me see. SQ. So the first equation involves STQ. The second equation involves TRU. And the third equation involves UPS, which are collinear. So what seems to be connected by segments, they're collinear. So RUT, QTS, and PSU. Given the first equation, the fact that SQ is double ST, what can we conclude out of that?
What can we conclude out of SQ is ST? Oh! If SQ is 2ST, that means ST is equal to STQ, and then as well as for the others.
Okay.
Wait. If ST is equal to SQ,
ST is not equal to X.
ST must be equal to TQ.
Yeah. So if ST is X, then that means TQ is also X.
What? Okay, so mahirap po. Hindi pa naka-scale kasi. I don't know.
Hindi naka-scale. All right, so it's not scaled, but well, just look at it abstractly. TR is triple TU.
TU is equal, TR is equal to 2, what, no. UR is equal to 2 TU.
So that means, what can we say about RU?
Well, actually, we can't say anything because it could, wait. No, RU is 2 times TU.
And since TU is Y, then
So
this is 2Y.
And then for UP naman, ba? somehow. 4 times US. So PS is 3 times PS is 3Z.
Yeah. Okay. So we're trying to find the area of the whole triangle. We already know the area of the middle triangle. The illustration dissects a triangle into 4 pieces. The middle piece, we know the area. So can we try to find the areas of the 3 other pieces?
Maybe.
I'm saying yes. All right. Yes, yes,
Times
indeed.
use
That's
times to use Heron's formula. Abo.
but we don't have the lengths of PQ, RQ, and PR.
No! Life
So we
study.
can't use we can't use Hurons. But
The if you know two sides and then the how do you know PSQ?
we don't know the angle PSQ.
We just know that USD is 5. Huh.
What can we say about those 2 angles that I marked?
Oh, they're supplementary. How
Mm-hmm.
could I not see this? Hmm. Okay, so USD is equal to ZX sine USD.
Sorry, what's that?
USD is
Let's call this. Let's call this alpha. So this would be 180 degrees minus alpha, or vice versa. Maybe the one lower is alpha, and then the double marked angle is going to be 180 degrees minus alpha. All right. Sige nga, gagawin natin ganito. This is alpha, this is 180 degrees minus alpha. We are right now trying to see if we can find the area of PSQ. We don't know the length of PQ, so we can't use Heron's formula. Well, we do have representations for PS and SQ as 3Z and 2X respectively. It's rather difficult to find the representation for their heights. But we need to be able to use the fact that the area of STU is equal to 5 units. The area of UST is equal to 5 units. So the question here is, can we relate the areas of STU and of PSQ, the 2 triangles here on the right side? The only one big thing that relates them is that they have those 2 angles which are supplementary to each other.
okay. So the area of USD is XZ sine of that 180 minus X. 180 minus
Mhm.
alpha.
1/2
And
XZ times sine of 180 degrees minus alpha,
since we
and that's
know
equal to 5.
about since since the dimensions of PSQ are in X and Z, we can find the area of PSQ.
As 1/2
So 1/2 three Z times 2X times the sine of sine of alpha.
but we know that 5 is equal to 1/2 times xz times the sine of 180 degrees minus alpha. Can we
Although
relate the sine? Just go ahead.
if 180 minus X is we can't know actually. It must be positive pala, sorry. The area must always be positive. So 180 minus X should be, but the sign of 180 minus X should be positive. X should
Mm-hmm.
be also positive.
Mm-hmm. Yeah, alpha and 180 minus alpha are in the first or
So
second
it means
quadrants.
they are the same. So kung ganun
So
pala,
that means
aba,
5 is 1/2 xz times
sine
the sine of alpha.
Oh, so what is 1/2? So that's PSQ is 6 times that. Yes, original. So PSQ is equal to 30.
Yes. All right. So kasi we ended up with 3 times 2 times 1/2 xz sine alpha, and that's 5. So there you go. PSQ, we can actually figure out its area is equal to 30 units. What about the other pieces?
The other pieces. Same attack. So,
So you cannot figure this out? You think we can move on to something else?
it's
All
now,
right.
it's kumbaga po, yung same na lang yung gagawin.
Okay, so find P, so we find PSQ. Let's find QTR and RUP similarly. So first, I'm not going to give a problem for which there is no solution, for which we cannot find the answer.
But,
Okay.
yung pala po, pag
So
winner count niya po, may isa pong triangle, negative.
then in that case, there is something wrong with the problem. There will be something wrong with the problem if that were the case. I think I should have maybe given this earlier because this is easier.
Yes, when the next example will be easier.
Kaso nga lang, I can't find it.
Oh,
Oh, wait. Can I can't find it. Mamaya na lang.
no.
All right. Another consequence of the law of sines is the angle bisector theorem.
Wait, what's this? I forgot.
The angle bisector theorem says that if you have a triangle like so,
And you bisect.
was A, B, C, and so you have the usual. So this is small b, and this is small c, and of course BC is small a. Suppose from A we draw this segment which bisects angle A.
Okay.
And then it meets the opposite side at a point, and it divides BC into these lengths, M and N. So of course, M plus N equals A.
I have a faint memory of this. I don't know. I forgot what what the relationship of M and R.
Sige lang. Let's see if you remember it correct.
M times N or something? Wait.
No, it's not. It's M over N
M over
equals
N equals M over N pala. Kala ko M over C or something.
C over B. All right. The angle bisector.
Wait, what? What?
The angle bisector from a vertex divides the opposite side into segments proportional to the other two sides. All right, so that's what we're saying here. The ratio of the division of the opposite side, so M and N, is proportional to C over B. So M partners with C, and N partners with B. Okay. So for example, if you have the following, let's say this is length 4.
Pero meron po
Sorry,
problem.
I just
Meron po akong problem po dyan eh. Kasi, let's say, AC is extremely long. Then that would also make BC extremely long. And also, that would also make BAC extremely big. Extremely wide. If we make AB very, very small, then the angle bisector of A will touch BC a very far distance from B.
Yes.
So if that happens, shouldn't it be different? The ratio of AB to AC is extremely small. Yet the ratio of BD to DC is not that
Wait,
small.
hold on. So if you're thinking of AB is fixed, and then you're thinking nung C is moving, is that it?
Hindi, C po is an extremely far away point from B. So that would make BAC a big angle.
So kaya nga, doesn't this describe that? Kasi B is here, and A is here, and vertex C is very, very far away, right?
Opo.
So imagine that point C from its current location, you're actually pushing it further and further to the right. So that's gonna make AC also longer and longer, right? But then mangyayari, there's no. Did you think there was something that's gonna be contradictory? Because let's say that this is C, and so mangyayari, nung BC is gonna be longer and longer and longer, and so AC is gonna be longer and longer and longer. But what's gonna happen is that as C is moving further and further to the right, the angle bisector D is also going to be moving further and further to the right. But of course, point D will still be between B and C.
Pero nga po,
So,
AB is constant eh. If BD
yeah, AB is constant.
So if if D keeps moving in the same direction as C, would that make BD over DC different from AB over AC since AC is moving, but AB is fixed?
They could still stay the same. For example, ganito, let's say C is equal to kasi ganito no, C palitan natin ng something definite. Let's make it 7. So AC is gonna be moving. Let's call it small b. That's gonna be changing. Pero kasi mangyayari, BD is gonna be, so mangyayari, BC is gonna be changing, but so is BD. So ito, let's call this 7Z, and then this is BZ. Nothing is really contradicted. As C is moving to the right, okay, and D is moving to the right, mangyayari, B is increasing, but then what's going to happen is that, I guess what that means is that Z, it's not just B which is increasing, Z is also going to be increasing. And as Z is increasing, then itong 7Z, BD, that would also be increasing. And we are not going to violate the fact that BD is to DC, 7Z over BZ is still equal to 7 over B. So that's still going to be satisfied.
Baka ano po ako eh, baka mali po yung parang figure ko po sa utak. Baka all this time D is not that far away naman from B. When it's moving, it's moving.
Actually, okay lang kasi ganito no, C is changing. So if you go back to the equation inside the box, C is equal to BM over N. The thing is, it's okay for C to be fixed, unchanging. B, M, and N, they could all be moving, and yet it's possible that the ratio BM over N is unchanging. Parang ganito, B is X squared. Palaki ng palaki. M is X cubed. Palaki ng palaki. And then N is X to the 5th power on its, or let's make it 2X to the 5th. So B is increasing, M is increasing, N is increasing, but it doesn't mean that this ratio is changing, it could still be constant. In fact, if you simplify, 1/2 constant. So there is nothing that needs to be contradicted. So I wonder if you feel like because B is changing, M is changing, and N is changing, typically BM over N is changing, but there really is nothing wrong if BM over N, when you compute in the end, there is nothing wrong if it actually stays the same. So this theorem is telling us that actually if AB is equal to 7, it's okay for it to stay 7, even as C is being moved further and further to the right. Does that address your concern somehow?
Somehow po.
All right. So you could have a whole quantity have its individual pieces changing, but the final computed quantity could actually end up staying the same. So pwede yun mangyari. Halimbawa, look at your age and your father's age. Diba? You're getting, both of you are getting older.
By
Your
the same age.
individual ages are changing, but the difference between your ages is constant. Diba?
Opo.
So you can have a constant quantity depend on moving quantities. And that's okay.
Opo.
All right. Okay. So ito, what was I gonna say? So ito, so what we're saying is that 6 is to 4, and if this is let's say 7 units, and then if we draw the angle bisector, okay, because 6 is to 4 as 3 is to 2, then that means the opposite side would have its individual segments. So they can be labeled as 3x and 2x. And so if we were interested in figuring out what the subdivision of that segment of length 7 is, then we know that 3x plus 2x is equal to 7. So that means x is 7 over 5. So that means if we have these lengths 6, 4, and then if this is the angle bisector, then that, and this has length 7, then it means that this longer segment is going to be 21 over 5. And this is going to be 14 over 5. All right. Have you encountered this theorem before, the angle bisector theorem?
I think so. Maybe po. I remember,
Iba lang po yung approach
iba lang, parang mas geometric lang yata po yung
Sa
approach.
geometry po, nag-gawa kami po ng
Ah, okay. All right. Actually, the angle bisector theorem, the thing is, I've only presented it so far. This is a purely geometric result. I am presenting it right now because we can prove it using the law of sines, and we can also prove it using using purely geometric means. All right. So don't worry. Let's do all of those. Let's look at some examples. And I'm trying to see if I have an example. All right. Wala akong makitang example right now. So let's just have a look at the proof. So I guess this in itself is this is the proof. And proof. Proof of the angle bisector theorem. Okay. Proof A, using the law of sines. Okay. A, B, C, small c, small b, and then here is the angle bisector. This is M, this is N, and let's call this angle theta. So that's also angle theta. All right. And then let's call the division point T. Using the law of sines, ganito, well, if you look at triangle BAD, M is opposite theta. And well, kasi we want, of course, to use the, we want a statement which involves M, C, B, and N. And the fact that those angles theta are equal to each other. And we notice that M is opposite theta. So from the left side, we see that M over sine theta is equal to, well, the other given relevant side is C. Okay. Let's call this angle, ano ba? Sige na nga, X.
Angle phi.
But then if, sige, angle phi. Good suggestion. Okay, angle, okay, sorry, not theta, but angle phi.
Theta mo ulit.
Oh, nga, theta ulit eh. But if that's phi, what is this?
The supplement of phi, or 180 minus phi.
180 minus phi. All right. So from triangle BAD, M over sine theta equals C over sine of phi. From triangle CAD, CAD, N over sine theta equals B over sine of 180 degrees minus phi. But we can simplify sine of 180 degrees minus phi, right? Sorry, 180 minus phi.
Opo.
This is going to end up being
Sine of phi.
Sine of phi. All right. So from our two equations, M over C is equal to sine theta over sine of phi. But from the second equation, N over B is also equal to sine theta over the sine of phi. So conclusion, M over C equals N over B. So in that way, this is a direct consequence of the, a consequence of the law of sines. Tapos since
law of tangents, law of cotangents, law of versines.
let's I remember a proof of this without using geometry. Sorry, without trigonometry.
Kailangan po na po ako without using geometry.
Okay, mas matindi kunwari if sinulat ko without mathematics. All right, impossible. So I meant without trigonometry. Okay, let's see if I can remember it. Actually, yeah, I think I could get it up. So ito nung theta M over N, B, C, and A. I'm gonna do the following. Okay. Through green. Through point B, draw this segment parallel to AN. So I'm gonna draw those arrowheads here to denote parallelism, but only so far as it meets the extension of CA. Let's call that E, and for consistency, let's still call this D. Okay. But because of the parallelism, all right, because AD is parallel to EB, Okay, since angle CAD equals theta, ito theta, then that means this angle should also be theta. All right, so angle CEB is also going to be equal to theta. Wait, let's write down the next. This is C, this is B, and okay, I've already written down M and N. Here is another observation. Okay, let me write it down with a different color. Yet again, because AD is equal to EB, since ito naman, this is what I want to observe. Since angle BAD equals theta, then angle ABE equals theta. So this would have to be theta. Do you see why? Because of the transversal, diba?
Opo.
If this is theta, then that should also be theta.
Opo.
But then if you look at points E and B, you have angle theta there. Okay, so angle ABE equals theta equals angle AEB, which means we have an isosceles triangle. ABE is isosceles. So that means AB equals
Wow! When ano po,
but
when you just discovered something.
yeah, but because AB is equal to C, then that means AE is equal to C,
No.
right? C din yun. And then
I
now,
see it already. I see it already. They are similar
kita mo na?
triangles. They are similar
Oo.
triangles. Oh
C,
no.
B, M, N.
Oh,
Okay?
it's a
So
similar
therefore,
triangle.
okay ba? M over C equals N over B. So
No.
same. Yes, 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 Joshua. Ain't it fun? All right. Wala pa akong ano.
Ito po yung alam namin
Yes,
po eh. Dito, ganito po yung nakita namin po na
na justification.
na justification po.
Without trigonometry, the other is using trigonometry.
Can you prove the law of science using this proof? Or not?
The law of science. Because the thing here in the second part is this is too specific because we are ano without using trigonometry. Because if you're gonna try to prove the law of sines, you need to work with two angles, angle alpha and beta, or angle beta and gamma. So the fact that you have an angle bisector, you're only talking about angle alpha. Pero kasi we are gonna have to talk about angle beta as well. So that's gonna be tougher. So I don't think from this we can prove the law of science, or at
No.
least in a way that I cannot see yet. Okay. Well, we've been talking about the law of science. Tagal-tagal na natin sa law of science. Now let's prove the law of cosines.
The law of tangents.
Gusto mo law of tangents? Ganito. Di ba A over sine alpha equals B over sine beta? Gawin natin ng sine alpha, palitan natin ng tangent alpha cosine alpha. So now we have A over tangent alpha. Yun nga lang, meron times cosine alpha equals B over tangent beta multiplied by cosine of beta. May bonus ka pa, cosine alpha and cosine beta. All right? Let's call that our law of tangents.
Literally.
Literally. Okay, basta masingit lang eh. Ganito, the law of cosines says that I think I already presented this last time. A, B, C. So A, B, and C. So there are actually three statements that we can come up with. A squared is equal to the sum of the squares of the other two sides minus two times,
Kala ko
yeah.
po ba, mukhang Pythagorean.
Actually, we are gonna go there. The Pythagorean theorem. The Pythagorean theorem. It's a squared is equal to b squared plus c squared minus 2 times bc times the cosine of alpha. So what happened here is on the right side is totally in terms of b and c. And how is alpha related to them? Alpha is the included angle. So when we say included angle between two sides, or the included angle of two sides, it's an angle between them. So if you look at the trio B and C adjacent and the included angle alpha, you can use those as ingredients to determine how long the other side is going to be. The thing kasi is, kunwari, you're given the three ingredients, alpha, B, and C. The start tayo sa A. So drawing natin to, array, we can extend this for as long as you want. And then from that, let's measure alpha. So let's say this is how big alpha is supposed to be. And then, so we use the ingredient alpha. And then given the length of C, here on the left, extend it based on the prescribed length of C. And then finally, using the length of B, extend this other side depending on how long B is. So given alpha, B, and C, that fixes how far points B and C could go. In other words, the length of BC depends on B, C, and alpha. Kumbaga, given alpha, B, and C, you don't really have any choice how long BC is going to be. Even if you want BC to be 7, nope, it's not going to happen because there is a relationship existing between A, B, C, and alpha, and that's what the law of cosines is telling us. A squared is equal to that. And then similarly, B squared naman. The other two sides are A and C, so this is A squared plus C squared minus 2 times AC, and the included angle is beta, minus 2AC cosine beta, and finally C squared is equal to, well, the other two sides are A squared and B squared, A squared plus B squared minus 2AB times the cosine of gamma. So this is the law of cosines. Let's prove it. Even though there are three statements, it is enough to prove only one of them, because the second and third equations are really just the first equation where you relabeled A, B, and C, and where you change the labels of the angles. Now, you said this looks like the Pythagorean theorem, and that's rightfully so, because what if uh, gamma is 90 degrees? So that's the angle at C.
Oh, cosine 90 is 0.
Yeah, cosine 90 is 0. So we're going to get C squared equals A squared plus B squared minus 2AB cosine 90 degrees, which is 0.
What?
And we end up with the familiar. Yeah. All right. So the Pythagorean theorem is therefore a special case.
Wow.
All right. Other consequences, ganito. Since we already talked about the case when alpha is 90 degrees and consequently cosine 90 degrees is 0, what if alpha is acute? Another situation we're going to look at, what if alpha, sorry, I keep on saying alpha, I meant to say gamma. All right, what
Alpha,
if gamma,
lahat po ng mga angles alpha.
yeah, lahat ng Greek angles, kahit Omicron, let's call it alpha. All right, alpha is acute and alpha is obtuse. If I just said I meant gamma. If gamma is right, cosine 90 degrees is gamma. What if gamma is acute? What can we say about cosine gamma versus when cosine gamma is obtuse? Compare mo, cosine 60 degrees and cosine 120 degrees.
They're just the same. Wait, no, they're not.
Same magnitude, not exactly the
Same
same.
magnitude, but they're the negatives of each other.
Yeah, they're negatives of each other. Cosine 60 degrees is positive or negative?
Positive.
Positive. Cosine 120 degrees is negative. So in general, if gamma is acute, what can we say about cosine gamma?
Cosine gamma is always positive.
And if gamma is obtuse, meaning gamma is going to be in the second quadrant where all x coordinates are negative, this is going to be negative. And so consequence is that if you look at the third equation, if cosine gamma is positive, that's going to make the last term minus something positive. All right. So mangyayari, minus 2ab cosine gamma will be negative. So that means c squared is less than a squared plus b squared. On the other hand, if gamma is obtuse, so cosine gamma is negative, that's going to mean negative 2ab cosine gamma will be positive, and so consequently, c squared will be greater than a squared plus b squared. All right. Actually, that can be imagined in the following manner. Let's say only the lengths A and B are given. So, but the angle gamma between them has to be acute versus the other situation where gamma is obtuse. And so imagine in the latter situation, gamma is bigger. So when you draw the figure, the first figure would maybe look something like this. A, B, and gamma. And then in the latter case, the opening of the angle would be much bigger. Sorry, I meant to use the same length now. Let me make A smaller. Okay. Okay. And then this time, bigger nung, so same length A, but the opening is bigger. All right, kasi gamma is obtuse. And then if you compare ito ng C, and this is C, it's in the latter situation where we find C to be larger. And in fact, C squared is larger than A squared plus B squared. In the former case where gamma is acute, we imagine C would be shorter. So it is actually such that C squared is less than A squared plus B squared. So parang nung transition is when C squared is equal to A squared plus B squared. That's going to happen when you have a right triangle. Okay. Before we go into challenging problems, let's start with the really more basic ones. In a triangle, A is 10 and C is 12, and then beta is 120 degrees. find the length of C. Actually, because we're using a special angle here, it's possible to figure out the length of C without using, sorry, find the length of B. Okay. How do we know we're going to use the law of cosines instead of the law of sines? Let's have a look at the figure. Beta is 120 degrees. Okay. So ito ng vertex B. This is 120 degrees. This is A, which is 10. So that means here is point A, and C is 12. So that means this other vertex is point C. Okay. If we're gonna use the law of sines, we can't use the law of sines because even though we're given 120 degrees, we don't know the opposite side. And if we're gonna use the law of sines, kasi, if you look at A sine alpha equals B over sine beta, if you want to be able to solve the triangle, you need to know the value of one of the two ratios. So that means you need to have a pair of an angle and the opposite side. But in our situation, we don't have such a pair where the side and its opposite angle are known. I mean, A equals 10 is given, but we don't know angle A. C equal to 12 is given, but we don't know angle C. 120 degrees is given, but we don't know its opposite side, small b. So we cannot use the law of sines. And well, that leaves us with the law of cosines, and that's something that we can use here because 120 degrees is the included angle between those two segments of lengths 10 and 12. All right, so b squared is equal to a squared plus c squared minus double AC times the cosine of beta. So a squared, that's 10 squared plus 12 squared minus 2. A times c is 10 times 12, cosine of 120 degrees. What's the cosine of 120 degrees?
Cosine of 120 degrees is just negative cosine 60 degrees, which is adjacent over hypotenuse is 1 over 2, 1 half. Negative, yeah, negative 1 half?
Yeah, negative 1/2. So we have 100 plus 144. So minus, it's going to be plus 120. So 244, 120. So we're going to have 364. Yeah, divisible by 4, no? 4 times 91. 91 doesn't have a square factor. So that means b is equal to 2 times the square root of 91 exactly. So that's what that is. B is 2 square root of 91.
91, is 91 prime po? Parang 91 yata is prime.
No, it's divisible by 7.
Oh, okay.
91 is 7 times
13.
times 13, but there's no perfect square factor in 91. And then, of course, with add trigonometry, nangyayari, A, C, this is 10, and this is 12. But because you have 120 degrees there, that means here you have 60 degrees.
We need trigonometry.
Well, I mean, not explicitly in terms of sines and cosines, but that base orange segment, that base in orange, so that's going to be 5. Tapos ito, this should be 5 square root of 3, therefore.
Therefore, we can find AC because it's Pythagorean.
Yeah, you have a right triangle. AC squared is 5 square root of 3 squared plus 17 squared. So, all right.
Abo.
Okay, another example. solve the following triangle. Alpha equals 14 degrees, B equals 5, and C is equal to 10. Okay. So B, we're not given beta. We have C, but we're not given gamma. And then what we have is alpha, which is the included angle. So that means we can use the law of cosines. A squared is B squared plus C squared minus 2BC cosine alpha. So we have 25 plus 100 minus double 5 times 10. That's the cosine of 14 degrees. So an approximation would involve using a calculator. So A would be approximately 5.2887075.
Kala,
Okay.
kala ko po, parang, di ba kayo nag-calculator? Bigla lang, nag-gana nila po eh. Sinunod na lang
I have
po.
my notes. I prepared. All right,
Kala ko
I
po,
prepared.
kala ko po parang yung calculator sa utak eh.
Oh no, I don't. That's not. That's not one of my. That's not one of the things I can do. And now that we have A, which is opposite alpha. So now we have the three sides, A, B, and C. We're now just looking for two more angles, beta and gamma. And how can we find beta and gamma? Actually, we just need one of them because the sum of all three should be 180 degrees. And we already have 14 degrees. So let's find, let's use the law of sines now. Sine of beta over 5 equals sine of 14 degrees over A. So dito papasok ng ano nung 5.2887075. And then what's going to happen is that sine of beta is going to be approximately 0.2287. And well, the thing with sine beta being equal to that is we're going to have to consider two candidates. Beta 1, based on the arc sine of 0.2287, this would be approximately 13.22 degrees. The other candidate would be the supplement, which is 166.8 degrees something. But based on this alone, can you see if both avenues would be productive, or is one
Beta
of
2
them
is
going to lead to a dead
impossible.
end? Which one? Beta 2? All
Beta 2
right.
is immediately not
Okay.
considered.
So not possible kasi when added to 14 degrees,
Is
lampas na tayo sa 180 degrees. Okay, so if beta 1 is approximately 13.22 degrees, then that means gamma. So that means isa lang ng beta. Okay. So therefore beta
if your calculator shows ano po, 179.999, is it technically still acceptable or not anymore?
I would say it's acceptable basta hindi pa siya 180 degrees. You just have the other
Kasi baka
angle.
yung calculator na po, nagmamali na. Hindi pala 180 na talaga.
And well, okay, posible ngang mali siya, pero we that's no different from working with a malfunctioning calculator, right? We can when we use a calculator, we trust it. All right, but of course it can be argued maybe mali ng calculator. Maybe that would lead you to be suspicious. But assuming the calculator is correct and the sum of beta and alpha is 179.9999 degrees, then that just means the other angle gamma is very small. So it would still be within the realm of possibility. If it's a calculator error, then that's a different matter.
Opo.
All right. Alright, kasi tagal na natin hindi nagpo-prove, di ba? Okay. Prove that cosine alpha over A plus cosine beta over B plus cosine gamma over C is equal to A squared plus B squared plus C squared over 2ABC
Oh
in any
no.
triangle.
Oh
Oh, come
no.
on. Why? Oh, no.
This is the new cosine law. Oh wait, this is also the second law.
Oh, yeah. Just put 1 over A times secant of alpha.
Oh no. Oh no. This looks very neat, but it looks hard.
It is very neat. It's hard. Nagano ka na agad. I mean, it is interesting. It is beautiful to look at.
Wait a minute. The two ABC at the denominator can multiply out.
Mhm. But then, ganito, the more complex side is the left side. Ganito, the left side involves the cosine of alpha, beta, and gamma. And the right side, A squared plus B squared plus C squared over 2ABC does not involve those cosines. So I think one way to go about this is to start with the left side, find a way to remove those cosines.
Mm.
Let's start with the first fraction.
Cosine
Cosine
negative
alpha over A. Can we rewrite that into something?
Cosine. This looks like the sine law. It's just in disguise. Probably.
E, probably,
Cos.
but it's not the. I mean, okay. Hint, we're just talking about the law of cosines. So let's use the law of cosines here.
Cosine alpha over a.
What statement involves cosine of alpha? Of the three statements from the law of cosines, can you
A.
recite to me?
Ow.
Sige,
A
recite.
squared plus. Huh? A squared equals B squared plus C squared minus 2BC cosine alpha. A squared. What? Cosine alpha is equal to B squared plus C squared plus A squared over
B
2B
squared plus C squared.
minus A squared over 2BC. Wait, this looks similar. This looks similar. I see, I see. I see how it became A squared plus B squared plus C squared. So if we use the cosine B beta over B, huh? It looks I can see the light at the end of the tunnel.
All right. See, just needed to be brave. Think of what law or
Bakit po
property
ABC?
uses cos. Hindi, kasi you have 2
Kaya
BC
pala
and
po.
then you're dividing further by A.
Tapos yung pag
All
in-add
right.
niyo po sa next, tingnan niyo po, pag yung next naman po, I know, sa B naman po, will probably
So
be
ito, what's cosine beta over B? What do you think is it gonna be?
A squared plus C squared minus B squared over 2ABC.
All right. And cosine gamma over C equals
B squared plus A squared plus B squared.
minus minus
9 po. C squared over 2AB.
over. Okay, so add natin A.
It looks perfect.
Yeah, it is perfect, right? So it's
No.
nice. Okay. 1, 2, 3. Okay. So now finally, when you add 1, 2, and 3, you get
How?
cosine alpha over A
How do people come up with these problems?
I think one way to come up with that is, in the previous problem that we just solved, we had to okay, we didn't really need to find cosine of alpha. Pero kasi ganito, no? Here in this illustration, so I said how given alpha, B, and C, you can find, sorry, given alpha, B, and C, you can use that to find A. But you can actually also go vice versa. Given A, B, and C, let's say you're given A, B, and C, we should be able to figure out what the three angles are. So in particular, you could solve for cosine alpha. So if you look at the first equation, that's precisely what you would use. If you were given A, B, and C, this is the equation we should use to be able to determine cosine alpha and eventually help us to figure out what angle alpha is going to be. So in general, if you were to solve for cosine alpha, what you're going to get is equation number one. And then if you look at equations 2 and 3, they're going to look similar, except that the denominators are going to be twice BC and then twice AC. But so you have three different denominators. You could make the denominators the same if you were to divide cosine alpha by A, cosine beta by B, and cosine gamma by C. So para kasi kapag same denominator, for whatever reason you're interested in, you could now add them together because now you have similar fractions.
Oh.
Okay, so if you add, so mangyayari,
Why does this look so?
double.
Why does this look so close to the ano po? The sign. The sign law of science.
I don't know, maybe it's a coincidence. Hindi pala double, single occurrence lang. A squared plus B squared plus C squared over 2ABC. I can't really say for sure why. Parang nagkataon lang na trig function over I don't know. I can't really say. Maybe nagkataon lang. But with the law of sines, if you look at the ratios, sine alpha over A, sine beta over B, sine gamma over C, the conclusion is that these three ratios are equal. If you're to look at the ratios cosine alpha over A, cosine beta over B, cosine gamma over C, they are not necessarily equal, but well, it turns out we can say something about their sum. In this case, yun nga, A squared plus B squared over C squared over 2ABC on the right. Okay, here's a problem. Oh, I haven't proved this pala, no? So let's prove this later, after this. The diagonals of rhombus A, B, C, D are 10 and 4. Okay. Rhombus CDEF is drawn with DE perpendicular to DA. Find the area of CDEF. So of course, let's draw first rhombus ABC. So 4 congruent sides, but unlike a square where the angles all have to be 90 degrees, that the angles don't have to be all 90 degrees. But we do have a parallelogram. And besides, the diagonals are not equal, they're not congruent. So we know that the rhombus can be drawn slanted. Then the diagonals are 10 and 4, so it's obvious this is the shorter diagonal, and then this is the longer diagonal. Do you know what can be said about the diagonals of a rhombus?
They are
What
like
relation?
height. I think I think it's the a rhombus is like sort of a height
Yeah.
parallelogram hybrid.
Mm.
So it's
Yeah. So
they both bisect each other and they are also perpendicular as well as being of equal. No, they're not equal lengths pala. Ah yes, they bisect
uh,
each other. Yun na pala
but
masasabi.
they bisect each other. So the longer diagonal is 4. So that means this is 2 and this is 2. The longer diagonal is 10. So that means this is 5 and this is 5. So that means we can actually figure out the length of the length of each side. Square root of 29. Because you have a right triangle with sides 2 and 5. So I think it's time to label A, B, C, D. Tapos this is A, B, C, D, and then we
Outside of ano
intend to
po?
draw.
Ano po,
Okay,
ano po na, trigonometry outside of triangles.
what do you mean?
Ito po, so does this mean, yung ano nga po, does this mean you can use trigonometry in any polygon at all? Because it can be decomposed into triangles.
Yeah, well, I guess. Oh, yes, 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 yes. So, of course, it's just an issue of whether you actually want to use trigonometry. So sometimes you don't need to use trigonometry. But yes, you can say you could decompose uh, it into triangles. But then the trigonometry you apply would be for each of those triangles, making up the polygon. Okay. DE is perpendicular to DA. So here we have DA. But if we're going to draw our rhombus, do you see that we have two choices? Because this is one possibility.
And also another possibility is going the same direction. This sort of the cis po na yung isa naman po yung parang trans na conformation.
So ganito, this is C, D, E, F. How would you describe the other options? Where should I put E?
Oh no, copy paste.
Of course,
No!
of course,
I
of
saw it
course.
coming. The select was too
This
much for me.
This is totally fair, man. This is fair. All right. So hold on now. Okay.
Some
CD. So ito, we have this 90-degree angle here, but then we could also have done it this way.
wait, there are actually infinite number of possibilities.
Infinite or kasi
And there are
CD.
finite, but I have so many ways to do it. I could continue it pag ganun po, nasa isang side. Pwede rin pong, I will just continue the AB and BC. And then I could do it on all four sides, each of those different possibilities.
Pero the labeling is in that order: C, D, E, F. So this is E, and then this is F,
Wait,
and then
bakit po
and
mas
then this
mahaba?
is.
Bakit po mas
Bakit mas mahaba? Kasi, okay, kung compare mo ng ano, CA is 4, CD is the square root of 29.
Hmm.
CD squared is 29, CA squared
Oh!
is 16.
CD is the same as CD. CD is the
Uh, yeah. So CD is longer than CA, but you have a rhombus there, di ba? So CF is the same as CD. So CF is longer than CA.
So, parang rotate niya po pag ano to, tapos nilagay niya po ulit.
Ayan. Pero we observe that oh wait, hold on, sorry. No. Kasi I drew this incorrectly. I had DE in my drawing perpendicular to DB, but actually the perpendicularity is with DA, not DB. Sorry.
Ayos.
Let's draw again.
Ha! Ano po?
Yeah.
Strikes again! Ha! Ha! Ha!
Mhm.
1-0.
Alright. Okay. DA. So
Hmm.
that's that doesn't look right. All right. Yeah. I hope it looks right now.
That's not the right angle po. Easy. Huh? It looks thin.
C D E F, and ito this time we would go this way naman.
Mm-hmm. Wait.
C D. No, C A kasi parang perpendicular. Okay, ito sa this.
Lah.
C D E F. Okay, so ito right angle there.
So it's
Okay.
technically not a rhombus anymore.
Nung C D E F.
Abo.
It has to be rhombus C D E F.
Well, that should mean that EF and AB are collinear.
What? It should mean that D F and
EF and AB po are collinear.
why would they have to be collinear?
Because
They
it,
they
you just,
they,
you
they
just,
don't have to be.
you just flip the rhombus po eh. They have to be.
But the angles are not necessarily the same. Ganito na. How about I ganito? How about I draw A B C D like so? Ganito. Kunwari mas na siya. Push down.
Now the drawing will be made even harder.
D A B C. All right. Or kasi when you draw the perpendicular to AD, mas kita natin that yeah, 90
What?
degrees.
No, no, no,
Diba?
no, no.
Mas kita mo. And then because AD is parallel to
Well,
BC, ito parallel sila no may orange. And then if ED is perpendicular, so you have that 90-degree angle, then you should also have this
so I see
90-degree
where
angle here.
saan po ako nagka-misconception. I did not realize
Ayan.
it does not depend on the ano. Kala ko po,
Yes.
I thought it, ano po tawag doon yung flip lang para sa
So you're not just flipping, all right?
Apo.
So at least now it's clearer. Okay.
It's a rhombus but doesn't have to be the same rhombus.
Okay, so it doesn't have to be congruent. Okay.
No, copy paste. No. Yes.
No, it's just erasing it. Okay. But hey, back to the problem. Find the area of C, D, E, F. Okay. Actually, nalimutan ko na nung gagawin. C, D, E, F.
Ano po na nawala.
Okay.
PTS.
Nawala na ako. C, D, E, F. We would need so we know the three sides, the three other sides, square root of 29. What we would need to know if we could figure it out is maybe the height. So itong mga strategies ko, figure out the height or see if we could figure out ng mga angles. For example, itong angle na to. How would knowing that angle help us? Kasi this is itong DE square root of 29, di ba? Tapos I could, if I look at CDE, CDE, the included angle is alpha, and then the two sides are square root of 29 both. So you have half of the square root of 29 times the square root of 29 times the sine of alpha. Okay, but then CDE is going to have the same area as CFE. Okay, CDE, dun sa orange rhombus natin, so CDE is the one that's higher. Okay, ito nung CDE, and then CFE would be this one naman, CFE. All right, and they're actually congruent. So this would mean that the area of rhombus CDEF is double that, 29 times sine of alpha. So that means we need to know what the sine of alpha is. But where are things coming from? Nung alpha is complementary to ADC. Okay, so see the right triangle, the right angle we have there. All right, ADC, if you call this, so if this is alpha, then that would make this the complement, 90 degrees minus alpha. We are not really that interested in alpha itself, but rather we're interested in sine alpha. All right. So in fact, even if it's not sine alpha that we know, let's say what we are able to figure out is cosine alpha. But if we know cosine alpha, we should be able to determine the value of sine alpha. And so we would have something to plug here. So let's go back to triangle ADCB, which involves 90 degrees minus alpha, because it's maybe from there that we might be able to say something about 90 degrees minus alpha. Let's call this let's call this theta. Instead of having to write it down as 90 degrees minus alpha, let's call that theta. Tapos, what?
Ano po, after pag ano po ginagamit na po octagon, so umabot na po ng omega.
Okay, so ito hanggang dalawang angles na. Ganito, look at ADC. Do we know all its three sides? ADC?
Okay, so there's 4, and then we know that there's square root of 29. And then since AD is equal to DC, we know all of its sides.
Yeah. All right. So from that figure, we know that 4 squared equals the square root of 29 squared plus the square root of 29 squared minus double the square root of 29 times the square root of 29 times the cosine of theta. So we can solve for cosine theta. So this is 29. So we have 58 cosine gamma. So that means cosine theta. Did I say gamma? Cosine theta is equal to 58 minus 16 over 58. Ano to? What's the numerator? 42, right?
42 over 58 is equal to, I don't know, I forgot.
29 over 29.
21 over
Okay.
29.
All right.
On the way.
So going back, so balik tayo dito ngayon sa ito nung theta, and then ito nung alpha, and we know that cosine theta is equal to 21 over 29. But because alpha and theta are supplements of each other, ano nung marerelate natin to cosine alpha, but this time using alpha?
Wait.
Let's say you have two complementary angles. which of their trigonometric functions are equal?
I could use co-functions, but
Yeah. Oh, why not?
literally co-functions.
So if cosine theta is 21 over 29, what can we conclude about gamma?
Oh, about alpha?
Sorry, what can, yeah,
Where's
I meant
gamma?
alpha.
Hindi,
Oh nga,
kanina
I
naman
meant
po,
alpha.
kanina po, alpha pag-gamma. Ngayon po,
Oo nga
na-confuse
eh.
po ako sa
So, you know what? Joshua, don't listen to what I say, just look at what I'm writing. So if theta plus alpha is 90 degrees, then that means, ano conclusion?
Uh, hmm. Cosine theta is equal to sine of alpha.
Yeah. So sine of alpha must be,
21 over 29 too.
right. And actually, yun na, 21 over 29.
What?
And
So
therefore, the
it's
area of
literally equal to
CD,
21, exactly.
yeah,
No, it can't be
21.
this neat. It can't be this neat. How?
Well, I'm sorry. I'm sorry. It's neat. But hey, let's not forget.
Hmm. There's another.
That there's that other configuration.
No.
And so ganito na, we tried to figure out let's use the following labels for nung alpha angle that we used is ito ng alpha. For rhombus CDEF, the angle at D. And what was theta? Theta is the angle at D for the original rhombus. So ito nung this is theta. So earlier, what happened was that theta and alpha were complementary to each other. For the second configuration, so if we are interested ultimately in the area of rhombus CDEF, this is still going to end up being 29 sine alpha. Okay, kasi CFE equals CDE. And for CDE, CD is the square root of 29, so ED is the square root of 29. Alpha is the included angle. So the area would still be given by that. Half of the square root of 29, square root of 29 sine alpha, and then double that, the area of CDEF. So it's still 29 sine of alpha. And
Why?
the angle of theta is the same. So cosine of theta is still 21 over 29. However, in the first figure, theta plus alpha
It's
had
90
a sum
degrees.
of 90 degrees, but that's not the situation this time. What relates alpha and theta? How are they related now to each other?
They're what? Wait. Theta is alpha minus 90.
Yeah, or
So
right.
there's
Yeah,
still
oh, kasi
co-functions. There's still co-functions.
yeah, so theta plus 90 degrees is going to give you alpha. So we are interested in the sine of alpha. In other words, the sine of 90 degrees. And sorry, oh gosh, what on earth did I just write? Sine of
Straight up
theta plus
sine of
90
90 degrees.
degrees. But what's this going to be?
Uh, that's actually sine. Wait, that's actually cosine theta. Wait,
Cosine theta, right? Tama ba?
Is it? Kasi
You know
it's
what? Let's just expand. Sine theta then cosine 90 degrees plus cosine theta sine 90 degrees. This is 1. This is 0. So sine alpha
It is
equals
indeed
cosine
cosine
theta.
theta.
All right. So
Wait,
therefore,
that's the same. Yeah.
ah, so therefore, uh, so of course this should have to be argued because the situation is different. So therefore, sine alpha is going to be equal to cosine theta, which is 21 over 29. And so therefore, CDEF is still going to have area exactly 21. And because I know you love exactly what just happened here, let's put this inside a big red heart.
Why?
Corny, I'm
Parang
sorry.
ano po eh, na?
I cringe.
Parang ano po eh. Parang,
I cringe.
parang ano po. Talaga.
Okay. Okay. Let's wrap this up. Ayoko bitina. Let's talk about why is the law of cosines true? And then maybe next time I could try to look for
Love
other law of cosines. Wala nang law of tangents. Hindi pa ba enough to? All right. Law of cosines. So, ganito. Let's, ganito, alpha.
Yung alpha talaga sinusulat. Yung alpha po sinusulat po ano parang ang liit ng parang butas.
Ito, sige, ayusin natin ito.
Ba't kaya ganun?
Alpha.
Lahat po,
So this
lahat
is
po ng
A.
pong references, yung handwriting
Okay.
po ganun.
So this is B and this is C, and then the lengths are ito. So this is ganito gawin natin. Let's put these in a coordinate system, meaning magdrawing tayo ng x-axis here and y-axis here. X-axis, y-axis. And then the length of AB is small c. The length of AC is small b. A is, of course, the origin, so the coordinates are 0, 0. What about the coordinates of point B? Given that B is on the x-axis and AB has length c. So that means the coordinates are C, 0. Now for point C, however, it's not that simple because AC is slanted. So let's draw the unit circle.
Well, to be honest, C is still findable.
In fact, that's what we're gonna do. So ito ng unit circle. So that means this is of length 1, and then because this angle is alpha, then that means this point that I'm highlighting, it's the point on the unit circle corresponding to the angle alpha in standard position. That means the coordinates are cosine alpha, comma, sine of alpha.
I just realized.
Remember that? All right, remember that?
Actually, if you know AC po and then sa circle, you can find out the coordinates of C.
All right. So ang situation lang kasi at that point is 1 unit away from A. Point C is B units away from A. So parang you're scaling further away from the origin by a factor of B, which means the coordinates of C should be what?
Cosine A times B and so cosine A.
Yeah. Times B. So B sine alpha. What were we interested in?
The area.
The length. We're trying to prove the law of cosines.
Wait, if you know the coordinates and then you calculate the area, can you use a reverse Heron's formula to find A, excluding the extreme that are going to be used?
All right, so before we find A, however, I think that's really a roundabout way to figure out A. Sorry, what's your proposition again?
My proposition po is that, di ba po, there's a ano po eh, using sort of a matrix, you can find the area of any rectilinear figure given all of its coordinates.
Yeah,
so now,
and we have that here.
Okay, from there, we can know the area, diba po? And then we know
Oh,
if B and C. So can we do sort of a reverse Heron's formula to find A?
uh, I have no doubt you can end up with an equation. The issue is that the
It's extremely
equation is going
hard.
to be rather complicated because you would need the semi-perimeter, di ba? So even if you're given B and C, okay, you would have, let's replace A by X. So when you write down your formula, S minus A, S minus B, S minus C, what you would have here is a fourth degree polynomial in X to the fourth power.
Oh no!
Tapos dito sa right side, 1/2 BC sine alpha. So to remove the square root, you're going to have to square that, but then you would have to solve a fourth degree polynomial equation.
But does that mean technically po it's solvable because there's a Ferrari equation?
Yes, yes. How exactly you do it is a different matter altogether. Kasi ganito, when you
Possible.
solve it, you would have your formula would depend on B and C and also alpha. I mean, alpha appears here on the right side, but here on the left side, well, I think suppose you could solve for fine. But when you do that, you're going to end up with 4 roots. You're going to have to identify which of those is correct.
Oh no!
So even if you end up, you're able to do that successfully, you would end up with 4 roots. You have to figure out a way of arguing that,
Ang
oh,
sagana po nga.
these other three are extraneous.
Ang sagana po
But,
nga. You will make
oh,
four of the possible A
all
po, and
right.
then you will find. Pero technically po, it's possible.
Yes, yes, it is possible. So think about it. Pero Joshua, don't we know the coordinates of B and C?
Oh wait, oh that's actually the difference. No, I'm so dumb.
All right. Anyway, you see it now. How would you find the length of A?
Distance formula.
Yeah, distance formula.
Why?
Ano?
It's just
Gusto mo pa mag-solve ng fourth degree polynomial equation? Or distance formula na lang tayo?
distance formula.
A is equal to the square root of B cosine alpha minus C quantity squared plus B sine alpha minus 0 quantity squared. Let's square both sides. B squared cosine squared gamma alpha minus 2BC cosine alpha plus C squared plus B squared sine squared alpha. The encircled part is B squared times sine squared plus cosine squared alpha. So that's B squared times 1. And so finally, A squared is B squared plus C squared minus 2BC times the cosine of alpha. So that, my friend, is the distance formula.
What? How did it actually became solved? What in less than 30 seconds?
All right.
Hindi po ako pwede maging mathematician kasi if I have enough time, I would do the Heron's formula for degree. When all
No, no,
but
it's fine.
I'm
No, 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 no,
blind.
no. All right. Hindi, ganito. It's part of the training. Seeing, ganito. I imagine what's gonna happen is that even if you try doing it that way, you're gonna get stuck, and then eventually that might be you to try to figure out, is there another way of doing this? Pero kasi sometimes, especially when you're solving something new, you are not going to see it right away. I just happen to have the advantage of having done this before. Yeah, but to be honest, I think I really like you trying to find your own way using Huron's formula. What was that a strategy that has
Oh, that
occurred
was
to
the
me
first thing
before?
that came to my
No,
mind.
it's okay. But the thing is, at least you are trying to think of options. You're trying to think of solutions. No, iba kasi, ano na, parang ano na, suko na, wala akong maisip. Sometimes, ganun talaga, hindi mo maisip. So, you sleep on it, try doing other problems. But ako, as a mathematician, basta meron pa akong naiisip na gagawin, I'm still happy. Kasi there's something that has to be explored. I despair when I've run out of things to try.
Opo.
All right. Okay. So I think that's it for now, Joshua.
Opo. I just realized like
Right.
I have no more time to solve yung fourth degree. All I have to do is just
Okay.
the distance formula.
I have some problems here. They're not really exactly related to the law of sines and law of cosines, but they are about trigonometric functions in general. So I'll write them later. The trigonometric functions, general law of tangents, kanina ko pa law of tangents and law of tangents. All right, ito.
Yeah. And kay blessing po kayo sa mga estudyante niyo eh.
The
Kasi po
perimeter.
yung kunyari po, yun sa Joshua, dati yung sinasabi ko po may nagturo sa kanya.
Opo.
Ayaw niya po yung tinatanong na ganyan. Tsaka yung ganyan po, hindi niya ma-prove eh. Basta yun, these are the...
Ah, okay.
This
It,
our lesson, ganun sabi po eh. Ayaw,
ay, nako. Medyo
kaya,
mahirap nung ganun kasi I think you should go ask and ask and ask. And I think I mean, if I cannot address it, I think it requires that a certain level of confidence. Halimbawa, kanina, Joshua was asking about Ian. Right now, I don't have an answer. So, isulat lang natin. Kasi, what can I do? Right now, I don't have an answer. So, ganun lang. Yeah, and it's not. I don't think, and that should not be a statement on parang I should be. But hindi ko alam yun. Kasi gano'n naman talaga. I don't know everything, and that's perfectly all right. So we
hindi,
can think about it.
it's na, hindi po sa parang pambobola sa inyo, pero you're a blessing because you're exactly what we were looking for. So exactly,
Well,
if
and
somebody who could explain that ganito po, yun,
mhm.
hindi lang po yung parang, kasi parang, ang feeling ko po yung, pagkat tinuturuan si Joshua before na ano po, parang fragmented yung masyado yung knowledge po na na-acquire niya.
Mm,
Geometry in one session.
pero kasi to be fair, addressing Joshua's demands are it's not an easy task then.
Ayaw nga po.
So,
Impossible.
kasi hindi
Impossible.
naman impossible. It requires a certain degree of expertise. I want you to be comfortable. I really want you to be comfortable exploring. And I think, yeah, you are exploring. So that's a good thing. Yeah. With others lang kasi, of course, I'm not judging them. It's all dependent din naman kasi on their experience.
Tsaka
So
yung
I just have to, be comfortable with this kind of approach.
Opo.
All right? Ito. Mamaya isusulat ko nung sige, anyway, we could stop here. I'll just continue writing the other problems.
Other problems po. Proceeds to write 10 others.
Yeah, you're giving me an idea, okay? You're giving me an idea.
Why did I say?
Oh, well, I mean, as mathematicians, our preoccupation is to solve problems. It's the heart of mathematics, all right? Okay. And I mean, ganito,
That's
Joshua,
double meaning.
you can't just, of course, listen to me. Dapat part of what you do is to struggle, and I think you're doing okay at your age. Of course, there are also other things that I'm gonna look into when I find the time. Okay, the ones that we set aside. All right. So.
Kaya lang hindi pa na sulat, hindi pa na transfer po na sa maganda.
All right. Oh. Lalagyan pa ni Joshua ng mga heart, di ba?
Cringe.
Cringe. All right. Ay. Diba kasi Joshua nilalagay mo pa sa pink paper or sa, or sa floral paper. Anyway, sige, Sir Jay and Joshua.
Thank you
Okay?
very much po.
Thank you po.
Okay. Bye. Have a good day.
Bye-bye po.
Take care.